In this section, we are going to discuss chains concept of LangChain. Also, we are going to discuss some update regarding the new version of LangChain, version 1.0.7. Also, we are going to discuss LangChain expression language, LCEL. A chain simply means connecting different steps so they run one after another. That you can see here, a simple chain example. We take a prompt, connect it to an LLM, and more such steps we can connect together using chain. Each step takes some input, does its job, and passes the output forward. That's actually where the name LangChain comes from, language plus chain, because we are chaining different language model components together. To build these connections, LangChain gives us the LangChain expression language. In simple, this pipe symbol. So with LCEL, LangChain expression language, we use this pipe symbol to join the prompt, the LLM, and many other LangChain components together. So if you check our previous code, here we have used invoke 2 times, one with prompt and one with LLM. But when we are using chain, just we have to invoke the chain. That's all, only the chain. The output you get is the same, but the workflow becomes cleaner and better structured. So please remember, behind the scenes, LangChain turns our code, means our pipe symbol, into a runnable sequence. A runnable sequence is an internal executor from LangChain _core.runnable that runs each step one after another. It automatically takes the output of one step and feeds it into the next step. So you don't have to pass values manually thanks to this runnable sequence. In simple terms, runnable sequence is equal to the engine that powers LangChain expression language pipes. It handles the flow, the inputs, the outputs, and the execution order. Hope all of you are clear with this, right? Behind the scenes, LangChain turns our pipe into a runnable sequence. So here we are going to discuss 2 of the most commonly used chains in LangChain. First, we are going to discuss simple sequential chain. Then we will discuss regular sequential chain. These 2 chains are used a lot because they help us run steps one after another in an organized and easy to control way. So now let's start with simple sequential chain. This is the most basic form of chaining. In this chain, the output of the first step becomes the input for the next step. So the first chain sends its result directly to the second chain. It's a clean and straightforward flow. One input, one output, step by step. So when we are using this simple sequential chain, our task moves in a simple linear direction. You can see the first chain has its own prompt and its own LLM. Same for the second chain as well. The second chain also has its own prompt and its own LLM. Both work separately but stay connected in a chain format where the input goes to a chain 1, then output of chain 1 becomes the input to chain 2, and the final answer comes from chain 2. As simple as that. This is the exact idea behind simple sequential chain. Before we move towards the coding part, let's also discuss regular sequential chain, which is also called as sequential chain. This chain is a bit more flexible than the simple sequential chain. Here, the next step does not rely only on the output of the previous chain. It can also take extra inputs from outside, and it can produce more than one output if needed. This is helpful when your workflow needs multiple inputs or when different results are required at the end. So in this flow, chain 1 has its own prompt and its own LLM. Same for chain 2 as well. Chain 2 also has its own prompt and its own LLM. But you can see chain 2 can receive both the output from chain 1 and additional input provided directly by the user. And at the end, chain 2 can generate multiple outputs as well, depending on what the workflow needs, right? So this is about regular sequential chain, that is also called as sequential chain. In short, we can use a simple sequential chain when the output of first step goes directly to the next step. We can use regular sequential chain when you need additional inputs or multiple outputs. Both of these patterns help us organize modern workflows using LangChain expression language. So now let's implement this. Let's jump to VS Code. So now let's first implement simple sequential chain. The question is what we are going to build. We are going to create a small MCQ generator using a simple sequential chain. The chain has two steps. In the first step, it will generate a quiz title from a subject. In the second step, it will generate 5 MCQs using that title. The output of step 1 automatically becomes the input to step 2. This is exactly how a simple sequential chain works. So now first let's create new file with name mcq_seq.py and let's import required libraries. From .env, let's import load_.env. From LangChain_OpenAI, let's import ChatOpenAI. Now the important step here, we need to change something. From LangChain_core.prompts, now we have to import ChatPromptTemplate. If you see our previous code, have imported ChatPromptTemplate like this, langchain.prompts, and then we have imported ChatPromptTemplate. But as you can see, just I have updated LangChain package, and currently I am using this version 1.0.7. So in this version, we have to import ChatPromptTemplate and also prompt template. From this langchain_core.prompts, we have to import ChatPromptTemplate, also prompt template. Please remember this, right? Now we can't use this. That you can see, they have changed package directly from LangChain to LangChain_core, right? So from now on, please use this new import path in all your code. This will help you to avoid errors and keep everything aligned with the latest LangChain updates that comes with this version 1.0.7. That's all, right? Now from LangChain_core.output_parsers, let's import string output parser. Now let's load our environment variable so we can access API keys. Now let's load our LLM. So for that, we have to use ChatOpenAI and model is equal to GPT-4o mini, right? And let's assign it to one variable LLM. Done. Now let's create the first prompt. This prompt will generate a quiz title. So for that, let's use ChatPromptTemplate class, and from messages here list of tuples, and first to pass system message. That's right. You create quiz titles and comma, and in the second let's write user message, which is called as human, right? And here give one short title about this placeholder subject that we will receive from the user. I think done. Format it properly so it looks better, and let's assign it to title_prompt is equal to this statement. Done. Our first prompt is ready. This will generate a quiz title. Let's create our second prompt. We are calling this prompt a question prompt, and let's change this. You are a quiz master, and let's change the human message as well. Create 5 simple MCQs. Also we can give A to D from this title. Means title generated by our previous prompt. Done. This prompt required title and generates 5 multiple choice questions. Now let's turn our prompts into runnable chains. So now let's create first our title chain. It take title_prompt that we have to pass to LLM, and here we can use string output parser. Please remember, it acts like a bridge, converting the model's structured output into a simple text string. This allows the next chain to easily use it as input, right? Because now it is converted into simple text string. Thanks to this string output parser, our first chain is ready. Now questions_chain is equal to question_prompt that we are passing to LLM. And again, we are formatting our output of LLM into simple text string. Now you can think of it like this. Prompt given to LLM, then to string output parser, then to the next prompt, then to the LLM, and finally to string output parser that will generate simple text string. Now let's combine them into a simple sequential chain because these two are not connected. So let's create our final chain. So first, our title underscore chain, which is given to our questions chain. And this is simple sequential chain. For better result, we can use this lambda function like this. Title, and in Python dictionary, we can pass title and title. So what this lambda function will do? It will extract title from this first chain and give it to this second chain. Nothing else, right? This is simple sequential chain. Again, the lambda takes the title from chain 1 and wraps into a Python dictionary. Yes, because chain 2 requires that format, right? In short, we are getting title from the first chain and passing explicitly to the next chain, our question chain. Finally, let's run the full pipeline. First, let's give subject. Shortly, we will take it from the user, computer networks, and let's invoke our final chain. With this subject, assign it to one variable result. Print the result. Done. Let's try to execute this. Clear this. Python mcq underscore sequence.py. Oh, great. You can see it's working fine. And this is our title. Networking basics. Connect and conquer. Great title, right? And our 5 MCQ questions with answer. You can see A, B, C, D. Great. Right? As per our given instruction in our question prompt. So this is working fine. Now let's create web application using Streamlit for this. For that, first we have to import Streamlit as st. Now let's give some title to our web app. st.title MCQ generator. This is the title of our web app. Then we have to take the subject from the user. Means user will enter this subject st.text underscore input and enter the subject. Done. Now if st dot button, user press this button, generate, then only execute this code. Also, let's create good sub header MCQ questions. In place of printing this on the console, we have to write st dot write. I think all done. Let's check. Clear this. Now we have to run like this. Streamlit run mcq underscore seq.py. Let's give again computer networks. Let's press this button, generate. Now you can see our app is working fine. You can see our 5 questions. And this is our title. Great. It is working fine. That you can see. Let's print our title properly. For that, let's terminate this. So we can also print title from here. Again, we have to use this. And here, let's use this tuple and st dot write this title and index 1. And we have to put inside this. And we are extracting from index 1. And we are writing title like this using this lambda function. Let's clear this. Let's check. Let's give now LangChain. Let's press this button, generate. Great. You can see it is printing title first. Thanks to this lambda function from here, right? And after that, it is printing these questions. You can see, right? So this way we can print title using this lambda function with this first chain, our title chain. Now let's implement regular sequential chain or called as sequential chain. Now we have implemented simple sequential chain. Now let's implement regular sequential chain. So this chain is a bit more flexible than the simple sequential chain, right? We discussed earlier. Here, the next step doesn't rely only on the output of the previous chain. It can also take extra inputs from the user from outside, and it can produce more than one output if needed. This is useful when your workflow needs multiple inputs or when different results are required at the end that you can see here. So in this flow, chain 1 has its own prompt and its own LLM. Same for chain 2. Chain 2 also has its own prompt and its own LLM. But chain 2 can receive both the output from chain 1 that you can see here and additional input provided directly by the user. At the end, chain 2 can generate multiple outputs depending on what the workflow needs. Let's implement this chain, regular sequential chain. It is also called as sequential chain. Here, let's create new file, MCQ and reg for regular sequential chain. Select this code, let's copy this code and let's paste it over here into our new file. Now we are keeping this first prompt as it is, but now we have to change our second prompt, this question prompt. Here I am adding difficulty level, which is provided by the user directly, right? So here one placeholder as it was, and here we are adding this new placeholder difficulty, and it is receiving title directly from this chain 1 and receive input for this placeholder directly from the user. So now here let's add difficulty, and we are creating select box, st.select box from Streamlit, and let's write select difficulty, comma, and let's give option simple or hard. Done. No need to change. Now the main part. In our final chain, we are passing only title to the next chain. Now here we have to pass difficulty as well directly to the second chain that we are receiving from the user. That's all. We have to change these things, right? We have added difficulty in our second prompt, also this in our final chain, and taking difficulty level from the user. I think done. And this is our regular sequential chain. Let's try to run this. Let's clear this and Streamlit run MCQ reg.py. Now you can see select difficulty, simple or hard. Let's select hard and again give computer networks and let's press generate. Let's see. You can see great title from GPT-4o mini, and you can see MCQ questions. Great. 5 questions. And this is the exact idea behind regular sequential chain that you can see. It takes the title coming from chain 1 and adds the user provided difficulty, combine them into one dictionary, so chain 2 receives the exact inputs needed to generate MCQ that you can see, right? Hope all of you are clear with simple sequential chain and regular sequential chain. Now let's move on. Now we are going to use multiple LLMs in place of one like this. So now let's create one new file, multiple underscore LLM dot file. Let's take our code. Let's paste it over here. Done. Now please remember one thing. I have also updated all the packages including Ulama as well. So previously we are importing like this from LangChain underscore community dot chat models, and we have imported chat Ulama. But now because of this update of LangChain, we have to import like this from LangChain underscore Ulama. We have to import chat Ulama. Please remember this. And from LangChain underscore Google underscore Gen AI dot chat models, we have to import chat Google generative AI. This is as it is, but we have to now import like this, not like that. Please remember this. We have imported this earlier in our previous code, but now onwards we have to import chat Ulama like that directly from LangChain underscore Ulama, right? So now we are not going to use this chat open AI. We are going to use Ulama and Gemini. Close this. Here LLM underscore Ulama. In place of this, we have to use chat Ulama. And for the model, we have to move to the command prompt because this LLM is running locally. Let's write first command Ulama and Ulama list. And this is the model. You can see currently I have installed these 3 models, Llama 3.2 latest and Llama 3.2 3 billion model. Use this. Let's copy this, close this, and let's use this model. And LLM underscore Gemini. And let's use this class. Chat Google Generative AI. Use model that we are using since long. Models / Gemini hyphen 2.0 hyphen flash that we are using since long, right? This one. And you can see because of new updates, it is generating this error, right? Let's move to our code. Done. Let's generate title using Gemini and question using Olama. You can see here we are generating title from Google Gemini. That title will be provided to our second chain, and using that title, our second chain will generate MCQs. For that, we are using Olama, means Llama 3.2, 3 billion model to generate MCQ questions, right? But the question is why we are using multiple LLM. So please remember, when we are building real world applications, using only one LLM model is not always the best option. Some models are really good at being creative. Some are better at polishing text, and others are fast or run locally. So instead of forcing one model to do everything, we just pick the best model for each step like this. It's like teamwork. One model creates the title, another model generates the MCQs. Using multiple LLMs simply gives us better results with less effort. And that's exactly we are doing here. A small pipeline where different models handle different parts of the task that you can see. Two models. Gemini will generate the title, and from that title, Llama 3.2 generate the MCQs. So this way we can use multiple models. Now let's try to run this. Streamlit run multiple underscore LLM.py. We want to generate quiz of AI. Let's make it hard. Press generate. You can see title generated by Gemini that you can see. And you can see MCQs are generated by Olama. You can see. Great, right? So this way we can use multiple LLMs as per our requirement, right? Let's move on. Now you can see currently our model means LLM is generating simple text output. But sometimes we want our output in JSON format that we are going to do now. Let's generate the output in JSON format so it becomes easy for any other program to read, reuse, or process it. JSON keeps everything structured and machine friendly, right? So let's do this. In place of this simple text, let's generate our output in JSON format. Let's move to our code. Stop this, clear this. So first, with string output parser, also we have to import JSON output parser. Next, in our second prompt, in human message, let's add return only valid JSON with keys, title, difficulty, questions. Done. So first, we have imported JSON output parser with string output parser. In our second question prompt, we have added this line as human means user message. Now in this, in our second chain, questions chain, let's remove string output parser because we want output in JSON format. So that's why we have to use JSON output parser. I think all done. Let's keep this st.write as it is. Let's open terminal and let's run this file because we have added JSON output parser in this file only. Multiple underscore LLM.py. Let's check again. Let's give title as machine learning. Let's keep it simple. Let's press this button, generate. You can see title has been generated. Now let's wait for MCQs. We want in JSON format. Oh, great. You can see our output in JSON format. It looks very nice, right? I hope all of you are clear with how to implement simple sequential chain, regular sequential chain, also called as sequential chain, how to use multiple LLMs, and how to format our output as per our requirement using string output parser or using JSON output parser. Let's move on.